Good morning, guys. Today we're going to be looking at factoring special products again. This is part two. And so we're still going to be working with the same special products, but we're going to continue practicing because there's different scenarios that can happen. And I want to make sure that I cover as many possible scenarios as I can. So this is second set of notes on the same topic. Okay, and so if we read here, it says, last class we learned about special products. If we can recognize special products in our problems, it simplifies the factoring process. Okay, and we talked about these two special products in particular, which were the difference of two squares and the perfect square trinomial. And so I hope in the last video you kind of got the hang of what we were trying to accomplish, what we were doing. A couple of things about the difference of squares. It's a binomial, meaning it's made up of two terms. The perfect square trinomial is made up of three terms. Some similarities are that the first and the last terms are perfect squares. And lastly, one difference is that for a difference of squares, and so I'm going to kind of highlight that feature, is that for a difference, there has to be subtraction. So remember that from the last notes. And then about the perfect square trinomial, one of the main differences was that when we're looking for the middle term, which is this one and this one, we're going to check to see if we get the middle term by multiplying 2 times the square root of the first term times the square root of the last term. And then depending if we have a plus plus or a minus plus, then it'll determine the pattern that we're going to follow, right? Just wanted to do a quick summary of the process. And so let's jump right into the examples. All right. So the first couple of examples, I think it's the first 6 examples, we're just trying to determine what, if I give you, a random problem, because on the test and on the review for the test, I'm not going to tell you, oh, this is a difference of squares, this is a perfect square trinomial. It's up to us to identify them. So if I give you a random equation, a random expression, you got to tell me what is it? Is it special or is it not? Okay. So for a difference of squares, remember it has to be made up of 2 terms. Okay. So for this one, it's made up of 2 terms. And remember the word difference for a difference of squares. Actually, let me just put an arrow. There has to be subtraction, right? Which there is. Then we asked, can we take the square root of the first term? Yes. Or we said, is the exponent even? That's what we said, right? Is this exponent even? Yes. And then, can I take the square root of 49 and get a whole number? Yes. So we have subtraction. We can take the square root of the first and the last term, and it's made up of 2 terms, so we have a difference of squares. Awesome. So let's jump to example 2. All right. So example 2, it has 3 terms, so it's not a difference of squares. So we have to check, is it a perfect square trinomial Remember, tri means 3, or is it not? So, for the perfect square trinomial, we have to check, can I square root the first term? Yes, right? The square root of n squared is n. So, yes, I can square root it. Can I square root the last term? Can I square root 9? Yes. Okay, and then the last thing we want to check is the middle term. Can I get it by multiplying 2 times a times b? Right, and remember we said last time that this is our a, this is our b. So let's see, what are we going to get if I multiply 2 times n times 3? Well, 2 times 3 is 6, and 6 times n is 6n. So I do get the middle term. So everything checks off. So this is a perfect square trinomial. Perfect square trinomial. All right, and then let's look at number 3. First off, we can say it's made up of 2 terms, so it's a binomial, so it might be a difference of squares. But remember, if it's a difference of squares, then we have to check to see if there's subtraction going on. And there's no subtracting. So this is not a difference of squares, and it's also not a trinomial, because a trinomial is made up of 1, 2, 3 terms, right? This is only made up of 2, so it can't be a trinomial either. Okay, so it's not a trinomial, it's not a difference, there's no subtraction, so we're going to say this is neither. Let me write that a little bit neater. Neither. Okay. Now let's go to example 4. Oh no, it's moved. Okay, that should fix it. There we go. Sorry about that. Example 4. We have 3 terms, so it might be a perfect square trinomial. We have to check, can I square root the first term? Well, what's the square root of 4? It's 2. What's the square root of m squared? M, right? Because when we square root, again, just a reminder, when we square roots, it divides the exponent in half. So half of 2 is 1m, right? Then can we square root the last term? What's the square root of 1? 1. So this is like my a, this is like my b, and I have to check the middle term, right? 2 times a times b. So what is 2 times 2m times 1? 2 times 2m times 1. Well, 2 times 2 is 4. 4 times m is 4m. So I could take the square root, so these check off, but this does not match with the middle term. The middle term we're looking to get is 8m. Right? It doesn't equal to 8m. So it's not a perfect square trinomial. It's not a difference of squares, because the difference of squares is a binomial. This difference of squares is only made up of 2 terms. So this is neither. All right. Example 5. This could possibly be a perfect square trinomial. Could possibly be. But here what we want to remember is in a perfect square trinomial, well, actually, let's do the steps. Let's do check the first term. Can I square root the first term? Yes, check. Can I square root the 25? It's 5. Check. Okay, and let's check the middle term. 2 times a times b is 2 times, oh, sorry, this is like my a, this is my b. So it's 2 times a times 5, which is going to give me 10a. So this matches. But what I want you guys to remember is in a perfect square trinomial, these are the patterns. I'm just going to write it out here. You can have the following, or you can have this one. And these two are on the first page. And so if you go back to the first page, notice that for a perfect square trinomial, you can have a plus or minus in the middle term, but in front of the last term, there always has to be a plus. There always has to be a plus. And so here, there is no plus. There has to be a plus. It has to be positive. So it's not positive. But it has to be. So it's not a perfect square trinomial. And it's not a difference of squares, because a difference of squares should only have 2 terms, but this has 3. So it's not a difference of squares. It does have 3 terms, but the last term has to be positive, and it's not. So this is also neither. Okay. Let's go, let me scroll up to number 6. Right. This is made up of 2 terms. So it could be a difference of squares. So for a difference of squares, you want to check, can I square root the first term? Can I square root the last term? Yeah, that's p squared. I can square root it. Check. Square root of 1 is 1. Check. And we want to check if there's subtraction going on, and there is. So it's two terms. There's subtraction between those 2 terms. I can square root the first and the last one. So this is definitely a difference of squares. Definitely a difference of squares. All right, let's go to the next one. And I think in this next one we're actually gonna factor. So let me scroll over there to the top of the next section. Okay. And so this is what I wanted to remind you guys of is, for a perfect square trinomial, the last term needs to have a positive. Okay, and the reason is when I multiply this, what's a positive times a positive? A positive b squared, right? What is a negative b times a negative b? Positive b squared. So it's the reminder there. Okay, so we're actually going to be doing the same steps that we've been doing. We square root the first term, square root the last term, and then write it in the following way. Making sure there's subtraction, making sure there's two terms for the difference, and then for the perfect square trinomial, making sure it has three terms, making sure that I can square root the first term and the last term, and then making sure that I have 2 times the first times the last, what we were doing just a little while ago. Okay, so let's jump right into it. Okay, so it says, actually, let me zoom out so that we can have the equations up there in view. Okay, so we have the equation here for difference of squares and the perfect square trinomial. Okay, so can I take, well, first of all, how many terms do I have? 1, 2, 3. So it's a trinomial. It's a trinomial. And then we're going to check, can I square root the x squared? Yes, that becomes x. Can I square root 49? Yes, that becomes 7. So this is like my A and my B. And then the last thing I want to check is, what is 2 times A times B? Sorry, it's going to, sorry about that. That's going to equal 2 times x times 7, which is 14x, and so that matches the middle term. Okay, and the question is, do we have plus plus or minus plus? Do we have plus plus or minus plus? It looks like we have plus plus. Okay, so we're going to use this pattern here. And so it's going to be parentheses a plus b. A plus b, but a is x and b is 7. So it's going to be x plus 7. X plus 7. Or we can also write it as x plus 7 squared. Whenever we multiply something times itself, we can write it as x, as that term squared, x plus 7 squared. All right, let's keep going. Let me zoom back in. We have 2 terms, so this could possibly be a difference of squares. We just have to check if there's subtraction going on, which there is. We have to check if I can square root. Can I square root the first term? Can I square root the last term? Yes, the square root of m squared is m. The square root of 64 is 8. So yes, I can square root them. So this is like my A, this is like my B. And it says at the top of the page, I'll just write it again, we're going to do A plus B times A minus B. But what is A, what is B? A is m and B is 8. So I'm going to write it m plus 8 and m minus 8. And notice that they're different, right? One has a plus, one has a minus. And so this is my answer. All right, let's go to example 9. All right, example 9, it looks like we have two terms. We want to check if there's subtraction going on. Subtraction going on? Yes. Can I take the square root of the first term? Square root of 9 is 3. Square root of y squared is y. Then I'm going to put, yes, we can take the square root. Can I take the square root? Can I take the square root of 25? Yes, that's 5. Okay, so everything checks off. This is my A, this is my B. So I'm going to do A plus B times A minus B. So it's going to be 3y plus 5 and 3y minus 5. And so this is my answer. All right, number 10. Number 10, we have 3 terms, so it might be a perfect square trinomial. So we just got to check a couple of square roots, right? Can I take the square root of the first term? Can I take the square root of the last term? Yeah, square root of 81 is 9. Square root of 4 is 2. Square root of p squared is p. So check, check. And then I just got to check the middle term. Check this middle term here. Is it equal to 2 times a times b? Remember, this is my a, this is my b. So I want to check 2 times a times b, but a is 2p, 2 times 2p. 2p. And then b is 9, right? So it's 9 here. Just double check. I want to check 2 times a times b. So I put 2 times a times b. Okay, so let's multiply it out. 2 times 2 is 4. 4 times p is 4p. 4p times 9. 4 times 9 is 36. So it's 36p. And so that matches the middle term. Okay, and so the next thing we want to ask is, do we have a minus plus or a plus plus? And it looks like we have a minus plus. So there's a pattern for the minus plus. The pattern is we're going to write a minus b, parentheses a minus b. Okay, it's going to be a, which is 2p, minus b, which is 9, and then the same thing again, 2p minus 9. Or we can write it as 2p minus 9 squared. All right, let's go to the next one. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . The next one is two terms, 1 and 36n squared. So it might be a difference of squares. Since we're checking for a difference, we want to check if there's subtraction going on. Yes, there is. Then we want to check, can I take the square root of 1? Yes, I can. Then we want to check, can I take the square root of 36n squared? Can I take the square root of 36n squared? The square root of 36 is 6. The square root of n squared is n. So check again. All right, so we have our A and we have our B. And so the pattern for the difference of squares is A plus B, A minus B. And so we're going to substitute. A is 1 plus B, which is 6n, and then the other one is parentheses A, which is 1, minus B, which is 6n. And so this is my answer. All right, number 12. Number 12 is made up of 1, 2, 3 terms, so it might be a perfect square trinomial. So we got to check, can I square root the 9? Yeah, that's 3. Check. Then we got to check, can I square root 16r squared? Square root of 16 is 4. Square root of r squared is r. So this is my A, this is my B. Okay, so the last thing I want to check is, can I multiply 2 times A times B and get the middle term? And we're looking to get 24r. Okay, so we're going to multiply 2 times A, which is 3, times B, which is 4r, which equals 2. 2 times 3 is 6. 6 times 4 is 24. Awesome, so we get 24r, which is the middle term. Oh, I forgot to check off that one. So everything checks off. I can square root the first and the last term. If I multiply 2 times A times B, it gives me 24r, which is the middle term. So everything checks off. The next thing we have to do is check, do we have a minus plus situation or a plus plus? It looks like we have a minus plus. So we're going to use this pattern. It's A minus B times A minus B. So that's kind of the idea, is if I have a minus plus situation, then I'm going to have A minus B twice. I have a minus situation, so it's A minus B twice. If I had a plus plus, then it would be plus plus. Okay, and then if I have a difference of squares like in number 11, then it's going to be a plus and a minus. So I guess the way that I remember it, and let me pick a different color here, is if these two, if I have a difference of squares, then the signs are going to be different. Because it's a difference of squares, I'm going to be using two different signs, right? A plus and a minus. If it's a perfect square trinomial, then they're both going to be plus or they're both going to be minus, but it depends on if I have a minus plus situation or a plus plus. Okay, so I just wanted to kind of clarify that part. And so let's substitute. So it's going to be parentheses A, but A is 3 minus B, but b is 4r, and then same thing again. Just copy it, right? But if I write something times itself, I can also write it as 3 minus 4r squared. Okay. All right. Let's go to the next one. Let me zoom out a little bit. Number 13. Okay. How many terms do we have? Looks like we have 2 terms, and so it could possibly be a difference of squares. We just have to check if there's subtraction, and it looks like it's not subtraction. Or let me put it this way. It's not subtraction, so it's not a difference of squares. It's also not a perfect square trinomial, because a trinomial would have 3 terms and this only has 2. So this is something that you cannot factor. So we call it, in math term, we call it prime. And yeah, and so again, prime means that it cannot be factored. Okay. Example 14. It looks like it could possibly be a perfect square trinomial because we have 1, 2, 3 terms. And so we got to check a couple things first. We got to check, can I square root the first term? Yes, I can. Check. Can I square root the last term? Check. I can. And then that means that this is my A, this is my B, and so I'm going to multiply 2 times A times B, and so that's going to give me 2 times M times 8. 2 times 8 is 16, so I'm going to get 16M. Does this equal to the middle term? Does it match with? No, it does not. Doesn't match. Okay, so then it's not a perfect square trinomial. And so we can't use the pattern, we can't use the rule. So if we can't use the rule, we can't factor it. And if we can't factor it, what do we call something that we cannot factor? Prime. Prime. So this was my, so we got the same answer for 13 and 14. All right, let's go to the last one. And the last one is a word problem. Oh, that's a good zoom. Okay. So last one says, factoring can be used when dealing with areas of squares and rectangles. For example, if the area of the rectangle below is the following, x squared minus 169 square units, find the length of the sides of the rectangle in terms of x by factoring. So it's basically telling us to factor I'm just going to write what it's telling us, but let me try to decide a color. Let me pick orange. It's basically telling us to factor this. So that's kind of like the problems that we've been working out. It's asking us to factor something. So let's do that. But keep in mind that it says that the area is equal to this. So I can write it in the following way. I can say the area is equal to x squared minus 169. And let's factor this. Is there subtraction going on? Yes. So let me point that out. So is there subtraction? Yes. Can I square root x squared? Yes. Can I square root 169? Yes, it's 13. So this is my A and my B. So we have a difference of squares. And so for a difference of squares, our area is going to equal to x plus 13 times x minus 13. Remember the pattern, right? For a difference of squares, it's a minus b, it's a plus b times a minus b. So that's what I wrote right here. A plus b times a minus b. Okay. So what that means is that if the area is equal to the multiplication of x plus 13 times x minus 13, and the area for a rectangle is length times width, then that must mean that this is the length and this is the width, because they're multiplying. So my answer would be that the length is equal to x plus 13. That's one answer. And the width is equal to x minus 13. Because it says in the instructions, find the length of the length of the sides of the rectangle in terms of x. In terms of x means that x is going to be a part of the answer. Okay, so if I know that the length is equal to this and the width is equal to this, then can we find the perimeter? Well, here's the formula for the perimeter. So then let's plug it in. So the perimeter is equal to 2 times L, but isn't L x plus 13? Right? Plus 2 times W, but isn't W x minus 13? Yes, right? So the perimeter is going to equal to, what do I do with the 2? Since it's outside, I can distribute, right? Let me use a different color again. So I'm going to distribute the 2 and distribute this 2. So let's see what we're going to get. 2 times x is 2x plus 2 times 13 is 26 plus 2 times x is 2x. And what's 2 times negative 13? Negative 26. Let me zoom out so I can have able to write it. And so let's combine like terms. What's 2x plus 2x? 4x. And then what's 26 minus 26? 26 minus 26. Well, these will cancel because they're something minus itself is 0, right? So this is my answer right here. This is the perimeter. The perimeter is 4x. All right. So again, guys, thank you for joining me in this video, and I'll be able to answer any questions you have in class. And so just have your questions ready, and we can go over anything that we went over in the video, just if you need clarification. But thank you for joining me, guys. Have a great day, and I'll see you in class.